Hello there and welcome to Earth with Nature. Imagining an alternate timeline, the foundations of a hypothetical coexistence. In this captivating exploration of speculative paleontology, we delve into a what-if scenario where early humans and dinosaurs share the same epoch, defying the 66 million-year gap that separates them in actual history. To ground this in authenticity, recall that dinosaurs dominated the Mesozoic era from approximately 252 to 66 million years ago, encompassing the Triassic, Jurassic, and Cretaceous periods, as established by fossil records analyzed by researchers like those at the American Museum of Natural History. Humans, specifically Homo sapiens, emerged around 300,000 years ago in Africa, postdating the Cretaceous-Paleogene extinction event triggered by an asteroid impact near Chicxulub, Mexico, which wiped out non-avian dinosaurs, according to isotopic dating and iridium layer studies published in journals like Science. Paraphrasing the original narrative, envision a world where this extinction never occurred, perhaps due to a cosmic deviation, allowing sauropods like Brachiosaurus, towering up to 25 meters tall with necks stretching like living cranes, to roam alongside our fragile, bipedal ancestors. These early humans, characterized by their rudimentary stone tools from the Paleolithic era, starting 2.5 million years ago with Homo habilis, would confront a landscape teeming with giants, where thunderous footsteps replace distant storms, as described in ethnographic analogies to modern hunter-gatherer societies. Educatively, this thought experiment draws from evolutionary biology. Human success in our timeline stemmed from cognitive adaptability, with brain sizes expanding from 600 cubic centimeters in early hominids to 1,350 cubic centimeters in modern humans, per cranial fossil analyses at sites like Olduvai Gorge. In this alternate reality, survival amid dinosaurs would amplify selective pressures, potentially accelerating encephalization, as theorized in studies by evolutionary anthropologists like Richard Leakey. Research analysis from paleoclimatology reveals the Mesozoic was warmer and more humid, with atmospheric CO2 levels at 1,000 to 2,000 ppm versus today's 420 ppm, fostering lush fern-dominated forests and conifers like Araucaria, which sauropods browsed upon, leaving bite marks in fossilized trunks examined in formations like the Morrison in the U.S. Early humans, adapted to African savannas with acacias and grasses, would face dietary shifts, experimenting with Mesozoic flora, some toxic due to secondary metabolites, as inferred from chemical analyses of amber-preserved plants. Authentically, fire mastery around 1.5 million years ago, evidenced by hearths at sites like Wonderwork Cave, South Africa, would serve as a crucial shield, not just for warmth but to deter predators, mirroring how indigenous groups like the Hadza use fire today. Imagine nocturnal scenes, campfires flickering under stars obscured by towering foliage, with low-frequency rumbles from passing Apatosaurus herds, creatures weighing up to 20 tons, per biomechanical models in nature shaking the ground, evoking awe and terror. This setup invites qualitative reflection on human ingenuity. Stories whispered around flames might evolve into oral traditions, predating cave art like Lascauz's 17,000-year-old depictions, but featuring toothed birds like Archaeopteryx instead of mammoths. Factually, dinosaurs varied immensely. Small theropods like Compsognathus, chicken-sized, could be hunted akin to deer, while titans like Argentinosaurus, up to 100 tons, dwarfed entire communities. Persistence hunting, a real strategy used by sand people to exhaust prey over kilometers, would falter against bus-sized beasts, necessitating innovations like atlatls, spear throwers, earlier than their 20,000-year-old archaeological debut. Tools from chert or obsidian, sharpened via knapping techniques studied in experimental archaeology, might target vulnerable spots, informed by modern wildlife biology on large herbivores. The environment's sense, trampled vegetation releasing volatile compounds, analyzed in paleoecology papers, would heighten sensory awareness, fostering vigilance. Curiosity, a hallmark of human cognition per neuroscientific research on dopamine-driven exploration, could lead to mimicry. Children imitating duck-billed hadrosaurs' calls, preserved in fossilized vocal structures suggesting honking resonances. Culturally, this could birth myths where earth-shaking entities embody gods, paralleling animistic beliefs in anthropology. Adaptation might include arboreal sleeping to evade ground predators, echoing primate behaviors in evolutionary trees. Water sources, vital for hydration, would be contested. Enormous crocodilians like Sarcosuchus, 12 meters long, per North African fossils, lurked in rivers, demanding guarded routines or inventive scoops, as analyzed in behavioral ecology models. Potential symbioses, like feathered dinosaurs scavenging scraps near camps, similar to wolf-dog domestication 15,000 years ago, could emerge, altering coevolutionary paths. Migration would follow dinosaur herds, not seasons, creating knowledge calendars based on patterns observed in trackways like those in the Paluxy River, Texas. Physically, evolutionary pressures might favor agility. Genetic studies on FOXP2 genes for coordination suggest accelerated mutations under duress. Diets enriched by dinosaur eggs, some melon-sized, per Mongolian nests, and extinct plants like cycads could yield novel nutrients, though with risks of alkaloids, per phytochemical research. Nighttime ruminations around fires would weave identity, blending fear with wonder, as humans navigated a world of living fossils. This paragraph, enriched with factual integrations from peer-reviewed sources like paleobiology and evolutionary anthropology, underscores the educational value of such hypotheticals in illuminating real scientific principles. Survival strategies and environmental challenges in a dinosaur-dominated world. Building on the foundational imbalance, this paraphrased regeneration examines how early humans might adapt survival tactics in a Mesozoic-like environment teeming with dinosaurs, infusing authenticity through paleontological facts and research analysis. Qualitatively, the original script's emphasis on scale contrasts human fragility, averaging 1.5 meters tall and 50 kilograms, with behemoths like Tyrannosaurus rex, standing 6 meters at the hip with bite forces of 57,000 newtons, per finite element analysis in journals like Anatomical Record, capable of crushing bone in one snap. Educatively, predators such as Velociraptor, actually dog-sized, not the oversized Jurassic Park depiction, based on Mongolian fossils described by Henry Fairfield Osborn, hunted in packs, their sickle claws analyzed in biomechanics studies showing slashing efficiency akin to modern raptors. Humans, reliant on cooperation evidenced by group hunting in 400,000-year-old Schöningen spears from Germany, would face amplified threats, perhaps innovating spiked shelters from conifer branches, mirroring defensive structures in ethnographic studies of Amazonian tribes. Fire, a pivotal technology with origins traced to controlled use 790,000 years ago at Gesher Benot Yaakov, Israel, would delineate safe zones, its smoke repelling insects and beasts, as thermal imaging research suggests. Cultural and evolutionary impacts of coexistence with giants. Paraphrasing the script's deeper layers, This paragraph regenerates the cultural and evolutionary ramifications of humans amid dinosaurs, embedding qualitative insights with factual authenticity and research analysis for educational enrichment. In this imagined world, human culture would be profoundly shaped by omnipresent giants, fostering myths where sauropods embody eternal forces, diverging from our timeline's sky gods in Mesopotamian texts, circa 3000 BCE, to earthbound deities inspired by seismic tremors from titanosaur footsteps, vibrations measurable in seismology studies of elephant analogues, scaled up for 70-ton beasts like Patagotitan from Argentine fossils. Qualitatively, the original narratives or translates to rituals. Paintings on cave walls depicting packs of Deinonychus, pack hunters per Yale's John Ostrom's 1969 analysis, serving as warnings, predating 40,000-year-old Indonesian art but infused with dino-specific symbolism. Educatively, intelligence acceleration under pressure aligns with theories in cognitive evolution. Encephalization quotients rose threefold in hominids over 3 million years, per fossil metrics, but dinosaur threats could hasten this via neuroplasticity, as stress hormone studies in primates suggest adaptive brain growth. Communities would necessitate larger sizes for defense, echoing eusociality in anthropology where group size correlates with predation risk, potentially birthing proto-languages earlier than the 50,000-year-old FOXP2 mutations linked to speech. Authentically, environmental immersion in Mesozoic biomes, ferns like Tempskia, tree ferns from Cretaceous amber, providing shelter would influence diets, with analyses of dental microwear showing early humans' omnivory adapting to novel proteins from small theropods, risking zoonotic diseases per paleovirology on ancient pathogens. Predators like Tyrannosaurus, with binocular vision for depth perception, per orbital reconstructions in biology letters, would demand innovative traps, perhaps pitfalls lined with stakes, innovating beyond 300,000-year-old wooden tools from Clecton-on-Sea. Water routines, fraught with threats from mosasaurs in coastal areas, marine reptiles up to 17 meters, per Kansas chalk beds, would hone cooperation, mirroring Inuit hunting strategies. Migration patterns, following hadrosaur migrations evidenced by bonebed assemblages in Alberta, would embed ecological knowledge into folklore, creating calendars rivaling Mayan astronomy. Evolutionary shifts might favor speed. Comparative anatomy shows human bipedalism optimized for endurance, but here selecting for sprint bursts against raptors clocked at 60 km per hour in simulations. Curiosity-driven imitation, children mimicking pachycephalosaur headbutting, dome skulls for ramming, precede analyses, could spark play-based learning, foundational to pedagogy. Food from eggs and plants like Benetitals, Scythe-like, with nutritious seeds, would diversify nutrition, though toxicity tests via trial and error mirror ethnobotanical knowledge in Amazon studies. Nighttime stories around fires, crackling amid conifer canopies, would forge identity, blending fear with reverence, as psychological research on trauma narratives shows resilience building. Rituals might include symbols for protection, akin to Australian Aboriginal Dreamtime tales but dinocentric. The imbalance, humans as intruders in a 165 million year dino reign, highlights fragility. Our 300,000-year span pales, per geologic timescales. Research from extinction dynamics, e.g., volcanic contributions to end Cretaceous die-off via Deccan traps dating, suggests humans could indirectly stress ecosystems via fire-altered habitats, fragmenting forests as satellite imagery shows in modern deforestation models. Qualitatively, This fosters humility over mastery, contrasting Industrial Revolution hubris. Adaptations like exploiting dino patterns, scavenging kills, or using cries as alarms echo mutualisms in ecology. Physically, stronger throws via atlateral evolution could arise, informed by biomechanical engineering. This educational lens, drawn from sources like Proceedings of the Royal Society, reveals how hypotheticals illuminate human resilience amid existential odds. Philosophical and ecological reflections on being out of place. Regenerating the script's philosophical coda, this final paragraph paraphrases the broader implications of humans in a dinosaur world, emphasizing educational depth through factual research and qualitative analysis on ecological and existential themes. Authentically, the Mesozoic's dino dominance across continents, from Antarctic cryolophosaurs to Asian therizinosaurs, left no niche uncontested, per global fossil distributions mapped in databases like the Paleobiology database, making human intrusion a profound mismatch against creatures evolved over eons. Qualitatively, this evokes a narrative of humility. Unlike our timeline's progression from hunter-gatherers to ecosystem shapers via agriculture 10,000 years ago, coexistence would temper confidence, viewing tools as mere defenses against invincible scales. As biomechanical models estimate T-Rex skin toughness exceeding leather. Educatively, extinction questions arise. Without the Chicxulub impact, dated to 66 Ma via tektites, dinosaurs might persist, but human fire use, altering 40% of landscapes in prehistory per charcoal records, could disrupt food webs, akin to Pleistocene megafauna declines linked to overkill hypotheses in quaternary science reviews. Research analysis from macroecology shows scale imbalances. Humans, with metabolic rates suited to small game hunting, would retreat to margins like swamps, echoing refugia in Ice Age studies where species survived in pockets. Predation would enforce constant vigilance, potentially accelerating cultural evolution. Myths of giant guardians could parallel Norse Jotun but grounded in real encounters, fostering religions of appeasement. Environmentally, Mesozoic climates with Pangaea remnants favored humidity, per oxygen isotope proxies indicating 5 to 10 degrees Celsius warmer globals, challenging human thermoregulation adapted to variable Pleistocene swings. Plants like equisetoms, horsetails, silica-rich for tools, would provide resources, but with herbivore pressures analyzed in trophic models showing cascade effects. Migration amid herds would weave human stories into dino rhythms, creating adaptive calendars. Evolutionarily, intelligence as a counter to size, human EQ of 7.5 versus dino averages of 0.5 per endocar studies might leapfrog, as game theory predicts innovation under asymmetry. Qualitatively, this underscores precariousness. Our history's neat line masks contingencies, like the asteroid's trajectory avoiding Earth, per orbital simulations in Icarus. Being out of place highlights adaptability. Niches in dino shadows could yield symbioses, like with troodontids, smart dinos with large brains, per Canadian fossils, paralleling human-canine bonds. Food chains enriched by diverse prey might sustain populations, though with risks from megaherbivore trampling, modeled in agent-based simulation. Ecological interdependencies and long-term ecosystem shifts. Extending the script's ecological themes, this paraphrased regeneration delves into the intertwined fates of humans and dinosaurs in shared habitats, offering qualitative insights backed by factual research and analysis for educational exploration of balance and change. Qualitatively, Humans as interlopers in a finely tuned Mesozoic web, where sauropods like Diplodocus, 30-meter lengths from Colorado quarries, per volumetric reconstructions, acted as ecosystem engineers by toppling trees, might inadvertently reshape landscapes through fire and foraging, evoking a narrative of unintended consequences akin to modern invasive species impacts but on a prehistoric scale. Educatively, trophic cascade models from ecology, applied to fossil food webs in the Journal of Ecology, suggest that human predation on smaller dinosaurs could alleviate pressures on vegetation, allowing regrowth of understory plants like horsetails, which in turn support insect populations vital for pollination in pre-flowering eras. Authentically, the warmer climate with elevated oxygen levels, up to 35% versus today's 21%, per geochemical proxies from amber bubbles, would boost human activity but heighten fire risks, potentially creating mosaic habitats that benefit agile species over lumbering giants, mirroring post-glacial recoveries in quaternary records. Research analysis from paleoecology posits keystone roles: human scavenging pterosaur kills, flying reptiles with lightweight bones from Brazilian Santana Formation, might disrupt vulture-like niches, fostering biodiversity shifts as seen in simulation studies of scavenger guilds. Culturally, this interdependency births stewardship myths. Tales of guardian herds where brachiosaurs' migrations fertilize soils via dung, nutrient-rich, percaprolite analyses showing seed dispersal, inspiring sustainable practices predating Incan terrace farming. Migration synchronized with dino patterns, trackways in Africa revealing seasonal movements, would integrate human calendars with ecological cycles, enhancing predictive knowledge akin to Polynesian navigation. Evolutionary feedbacks could emerge. Genetic drift models predict human adaptations to dino pathogens, like immune boosts from HLA gene variations studied in ancient DNA. Food webs enrich, harvesting eggs from Maiasaura nests, colonial sites in Montana evidencing parental care, provides sustenance but risks overexploitation, as population dynamics warn of crashes. Qualitative depth reveals harmony amid chaos. Witnessing a forest renewed after a herd's passage instills respect, contrasting our exploitative history post-industrial revolution. Predation dynamics shift, deterring carnosaur raids with noisemakers from hollow logs, informed by ethnomusicology on alarm signals. Symbioses deepen, feathered maniraptorans, ancestors to birds, per-feathering fossils from Siberia, might cohabit camps for mutual pest control, paralleling human-raven interactions in folklore. Physically, altered diets from dino-adjacent flora like nutrient-dense cycthed fruits, though alkaloid-laden per toxicological assays, could influence gut microbiomes, boosting health or causing ailments. Long-term, human activities might accelerate extinctions, as overkill hypotheses apply to megafauna declines, modeled in global change biology. Yet, resilience shines. Niches in dino shadows yield innovations like biomimicry of armored plates for shelters. This educational lens, drawn from sources like ecology letters, qualitatively weaves human influence into ancient ecosystems, highlighting fragile interdependencies, existential legacy and hypothetical futures in a merged timeline. Concluding the script's philosophical extension, this final paraphrased paragraph regenerates reflections on the enduring legacy of human-dinosaur coexistence, embedding qualitative profundity with factual authenticity and research analysis to educate on temporal contingencies and human potential. Qualitatively, this merged era, where the asteroid's deflection, simulated in astrophysics models from Icarus Journal as a mere orbital tweak, preserves dino lineages, positions humans as fleeting sparks in a vast chronicle, fostering a worldview of cosmic humility that tempers ambition. Unlike our timeline's triumphant narrative from Renaissance exploration to space age. Educatively, deep time perspectives from geology reveal dinosaurs' 180 million year saga outlasting potential human spans, per extinction rate calculations showing vulnerability to perturbations like volcanic outgassings from Siberian traps analogues. Authentically, cultural legacies might manifest in artifacts. Carved amber talismans depicting Archaeopteryx flights, transitional bird dinos from Solnhofen, with feather imprints analyzed in microscopy, symbolizing aspiration and predating Egyptian scarabs but infused with aerial wonder. Research analysis from futurology posits accelerated progress. Under dino pressures, technologies like early agriculture, perhaps domesticating fern crops in cleared zones, could arise sooner than the 12,000-year-old Fertile Crescent evidence, as adaptive models predict. Migration epics, chronicling journeys alongside migrating iguanodonts, bipedal herbivores with thumb spikes, perfunctional morphology in Acta Paleontologica, would encode geography into myths, rivaling Viking sagas. Evolutionary trajectories diverge. Selective breeding of symbiotic dinos, like small compsognathids for pest control, chicken-sized, per French fossils, mirroring dog domestication but yielding feathered companions with enhanced cognition. Food innovations from hybrid ecosystems, blending savanna grains with Mesozoic nuts, might sustain megacities earlier, though climate volatility, per Milankovitch cycle influences on ice-free poles, poses challenges. Qualitative musings evoke wonder, stargazing amid bioluminescent skies, pondering if dinos pondered the heavens, contrasting anthropocentric philosophies like Descartes. Predation's shadow lingers, but triumphs in lore, defeating a Giganotosaurus, South American giant rivaling T-Rex, per size estimates, becomes foundational legend. Symbioses culminate in coevolution, human intelligence paired with dino strength, as hybrid ecology theories suggest mutual advancements. Physically, longevity increases via medicinal plants discovered in dino-rich biomes, informed by ethnopharmacology. Long-term futures imagine harmony, humans as stewards, preventing extinctions through knowledge, unlike our biodiversity crises. Yet, existential risks, another asteroid or supervolcano, underscore fragility, as chaos theory in paleontology warns. This paraphrase, grounded in proceedings of the National Academy of Sciences, qualitatively contemplates how such a timeline reshapes human destiny, blending awe with scientific insight in Earth's alternate chapter.
Qualitatively, facing the raw power of behemoths like the horned Carnotaurus, South American abelisaurid with vestigial arms, per muscle reconstructions in Journal of Vertebrate Paleontology, would hone human wits into sophisticated defenses, narrating a saga of wits over might that parallels Sun Tzu's art of war but rooted in prehistoric skirmishes, where evasion and traps supplant direct confrontation. Educatively, game theory models from behavioral economics illustrate how asymmetric threats promote asymmetric warfare. Simulations in evolutionary anthropology show that guerrilla tactics against larger foes enhance survival rates, here applied to ambushing solitary tyrannosaurids by exploiting terrain, diverging from our timeline's organized battles post-Bronze Age. Authentically, fortification innovations arise, earthworks reinforced with petrified wood from Araucaria forests, conifers from Patagonian deposits, per durability tests, create barriers against charging herds, predating Roman limes but scaled for mega-herbivores like Triceratops, whose charging speeds reach 30 km per hour per kinematic studies. Research analysis from military history suggests rapid tactical evolution. Ethnographic comparisons with Zulu impis reveal how mobility counters size, potentially leading to mobile units scouting for Carcharodontosaur territories, giant shark-toothed predators from Africa, with jaw gape analyses in Acta Paleontologica Polonica. Culturally, war dances instill discipline. Rhythmic stomps mimicking theropod strides build morale, akin to Maori haka but invoking dino ferocity to psych out rivals, human or beast. Migration conflicts with territorial dinos, like defending passes from allosaur packs, embed strategy in folklore, rivaling Spartan legends. Evolutionary selections favor cunning. Psychological studies on deception link it to prefrontal cortex development under predation. Food defense strategies. Communal stockpiles guarded by noise deterrents from conch-like ammonite shells, fossilized cephalopods from marine layers, per resonance properties. Qualitative tales dramatize heroism. A clan's stand using fire walls against a rampaging Spinosaurus, evoking epic resilience. Predation avoidance through camouflage, mud blends mimicking dino hides, informed by optics research. Symbioses in defense, allying with pack dinos like velociraptors for mutual protection, paralleling medieval nighthound bonds. Physically, training regimens boost endurance, as physiology papers predict. This paraphrase, authenticated by journals like Journal of Conflict Resolution, engagingly educates on how peril forges strategic mastery, blending tension with triumph in an alternate history. Qualitatively, in this timeline where the Chicxulub impactor veers off course, per orbital perturbation models in monthly notices of the Royal Astronomical Society, humans and select dinosaurs might forge unbreakable bonds, narrating a utopia of merged destinies that transcends our solitary evolution, imagining riders on tamed ornithomimids, ostrich-like speedsters from Canadian formations, clocking 60 km per hour in gait analyses, as partners in exploration. Educatively, coevolution theory from biology posits mutual adaptations. Genomic studies in Evolution Journal suggest gene flow via selective pressures, potentially yielding humans with enhanced senses attuned to dino vocalizations, like those of Parasaurolophus crests, resonators producing infrasound, per finite element modeling in paleobiology. Authentically, domestication paths emerge, herding small hypsilophodonts, agile bipeds from Australian polar forests, per cold adaptation evidence, for labor, predating cattle farming but leveraging their endurance, as ethological parallels with reindeer herding indicate. Research analysis from systems biology forecasts ecosystem synergies. Network models predict stabilized food webs through human-dino alliances, mitigating extinctions unlike the megafaunal collapses in our Pleistocene. Culturally, hybrid festivals celebrate unions, feasts blending human crafts with dino displays, akin to Celtic Beltane but featuring feathered theropod dances. Migration as joint ventures, caravans with sauropod escorts for protection, encoding symbiotic lore in epics. Evolutionary convergence, shared traits like pack loyalty, as mirror neuron research implies empathy cross-species. Food symbioses, cultivating fungi on dino dung for nutrition, per mycological studies. Qualitative visions inspire, a world where children play amid gentle giants, fostering empathy over fear. Predation reframed as guardianship, with trained raptors as sentinels. Symbioses peak in bioengineering, grafting dino traits via folklore-inspired breeding. Physically, health benefits from shared microbiomes, as immunology predicts. Long-term, this harmony averts crises, as sustainability models affirm. This engaging educational close, grounded in bioscience, qualitatively envisions convergent paths, illuminating boundless possibilities in a dino-human odyssey.
Venturing into cosmic ray chronicles, galactic supernovae bombard Earth with high-energy particles, planetary science facts from ice core muonium records showing flux increases during magnetic minima, potentially triggering mutations that accelerated evolutions or extinctions for hypothetical ancient societies. Detectors like the IceCube Neutrino Observatory capture these echoes, paralleling models for exoplanet biospheres battered by stellar explosions. Question: how do these invisible storms underscore Earth's vulnerability in a galaxy of violent births and deaths? Metaphors of rays as celestial arrows pierce the narrative, with beryllium-10 spikes in sediments marking past assaults. Transitions philosophically to habitability's shields, as seen in Jupiter's magnetosphere protecting its moons. Encourage exploring the Carrington event of 1859 as a mild analogue, hinting at tech-disrupting potentials. This fosters reflection on cosmic interconnectedness. Exploring stellar evolution ties, the Sun's luminosity increases over billions of years drive Earth's long-term warming, planetary science facts modeling a future moist greenhouse state akin to early Venus, where runaway evaporation dooms oceans. Reflect on how this stellar aging weaves fragility into cosmic timelines. Educational examples include simulations via general circulation models, revealing tipping points matching those for habitable exoplanets around aging stars. Metaphors of stars as ticking clocks pace the wonder, encouraging research into Proterozoic oxygenation events tied to solar output. Broader implications ponder universes where stellar stability is the rare gift, amplifying Earth's precious now. In extending this boundless exploration through volcanic fires, paleoclimatic whispers, astrobiological tenacity, cosmic ray tempests, and stellar evolutions, we've uncovered more layers of Earth's enigmatic tapestry, intertwined with exoplanet enigmas and universal fragilities. Let these revelations ignite your own quests, and remember to engage with Earth with nature. Your insights in the comments propel our shared journey into the stars. Science and technology examples abound, submersible probes sampling deep-sea trenches, parallel to proposed Europa landers. Emotional investment grows from realizing life's ubiquity yet ephemerality, with 99.9% of Earth's biomass microbial, a silent majority echoing galactic potentials. Seamlessly, this highlights the universe's biotic mosaic, fostering reverence for our shared fragility. As we deepen this interstellar tapestry, let's traverse the realms of plate tectonics, where continental drifts sculpt Earth's surface over eons, planetary science facts revealing subduction zones that recycle crust into the mantle, erasing surface evidence of ancient civilizations, much like how gravitational instabilities in young exoplanet systems devour protoplanetary disks, as observed by the Atacama Large Millimeter-Submillimeter Array, ALMA. Envision these shifting plates as the planet's restless puzzle pieces, their movements tracked through GPS networks and paleomagnetic data, correlating with biodiversity hotspots and mass extinctions, perhaps compounded by hypothetical mega-engineering projects that altered fault lines, paralleling the tidal disruptions on moons like Europa, where cryovolcanic fissures hint at subsurface oceans sustained by flexural stresses. Reflect introspectively. If Earth's tectonic ballet has swallowed the ruins of forgotten eras, how does that fragility mirror the chaotic dances of worlds in multiplanet harmonies, where resonances amplify orbital eccentricities into catastrophic collisions? This educational layer fosters depth through metaphors of continents as nomadic wanderers, their journeys inscribed in archaeolite sequences, ancient seafloor remnants uplifted into mountains, analyzed via electron probe microanalysis to uncover elemental signatures of past hydrothermal activity. Transitions broaden to philosophical reflections on cosmic multiplicity, portraying Earth as a dynamic canvas in a gallery of static worlds, its plate motions fostering atmospheric renewal unlike the stagnant lids of Venus or Mars, imaged by the Magellan and Mars Reconnaissance Orbiter missions. Encourage your exploration of the Wilson Cycle's records, detailing supercontinent assemblies like Pangaea 300 million years ago, with seismic tomography revealing slab graveyards in the mantle that echo the potential for hidden artifacts, akin to models for super-Earths with vigorous convection. In this unhurried immersion, facts like the Himalayan uplift's ongoing rise, driven by India-Eurasia collision and influencing global monsoons, parallel exoplanet scenarios where mountain building affects habitability by weathering silicates to draw down CO2. Vivid descriptions paint rift valleys as birthing scars, their basalts cooling into columnar joints that geochronology dates, suggesting pulses tied to mantle plumes possibly influenced by artificial deep core manipulations in speculative narratives. Science and technology marvels include ocean bottom seismometers detecting microquakes, similar to those proposed for monitoring Io's seismic activity via future orbiters. Emotional engagement arises from awe at tectonic's dual role as creator and destroyer, with 80% of Earth's heat flow venting through mid-ocean ridges, a lifeline for chemosynthetic life that underscores resilience amid galactic perils. Broader implications tie to the universe's tectonic diversity, where over 4,000 confirmed exoplanets may host plate tectonics essential for carbon cycling, yet vulnerable to stellar bombardment. This seamless narrative highlights fragility's grind, inviting a therapeutic embrace of our ever-shifting home. Venturing into asteroid impact legacies, cratered landscapes bear witness to celestial bombardments, planetary science facts from the Chicxulub structure in Mexico linking it to the dinosaur extinction 66 million years ago through shocked quartz and tektite distributions, events that could mask or mimic technological cataclysms, echoing the impact-induced atmospheric stripping modeled for early Mars via the MAVEN mission's isotopic data. Picture these cosmic intruders as wandering harbingers, their effects quantified through crater counting on Luna Maria, revealing a late heavy bombardment phase 3.9 billion years ago that reshaped biospheres, perhaps interrupting nascent intelligences much like how near-Earth object surveys with telescopes like Pan-STARRS track potential threats today. Question for quiet contemplation: if Earth's scars from skyfallen stones have veiled histories of upheaval, how might that parallel the battered surfaces of exomoons, where impacts excavate subsurface ices into transient atmospheres? Building investment through vivid educational metaphors, we see impact basins as planetary pockmarks, their ejecta blankets dissected by laser altimetry to map subsurface structures, uncovering iridium layers that isotopic ratios tie to extraterrestrial sources. Transitions to broader astronomy's wonders philosophize on multiplicity, Earth as a survivor in a shooting gallery of solar systems, its moon stabilizing torque mitigating obliquity swings that asteroids might exacerbate, as inferred from dynamical simulations of the TRAPPIST-1 system. Encourage researching the Vredefort Dome in South Africa, the world's oldest large crater at 2 billion years old, with metamorphic rocks hinting at hydrothermal systems that could have cradled post-impact life recovery.